Cool. We are live. Let me just do, what can I do? Let me start with this. There we go. Let's see. What would be the ideal camera setup for me? Like this? Nah, it's too. Yeah, I guess that'll be it. Cool. Let me just remove the banner. Where is it? There we go. No banner for now. Thank you all for joining. Cool. So let me just share quickly first the link for you to register. Okay. Copy this, paste it here. Cool. Nice. Awesome. So let's do a little bit of a focus here. Hello, my name is Bully. I'm a robotics and telecommunications engineer. I'm also a pod leader and a streamer. So yeah, if you need any help with about the fellowship, about the PE Meta PE fellowship, or the fellowship, the open source one, hey, then ping me on Discord and I'll be able to help. Okay, cool. Hey, Mena, nice. Okay, cool. So today's stream is about Arduino, about electronics. Okay, I think Joss have like streamed 2 days ago, like 3 days ago, something about IoT. I wanted to go to the basics more, and Arduino has a lot to do with IoT. So cool. Let's start with, okay, first of all, I am going to use tinkercad.com. Yep, cool. Okay, so I'm gonna use I'm gonna use Tinkercad. Okay. Tinkercad is a page where you can simulate Arduino in a friendly way. So it's free. Okay. I send this to you if you want to follow with what I'll be doing, which would be great. So in the meantime, while I explain some other stuff, you can go and log into Tinkercad if you don't have an account. Okay, nice, awesome. So let's do this. Let's start with, let's see if this draws. It does, cool, okay. So working with Arduino, working with microcontrollers, working with IoT stuff, we always have to know the basics because it's easy to burn stuff. Okay, like really easy to burn stuff. So you can burn your Arduino. Happened to me. It's not funny when it happens to you. You can burn capacitors; they explode. You can burn lots of things, which wouldn't be that fun. But that's why we'll take a look about stuff that we have to know before connecting. Okay, cool. Because we're going to simulate everything. Then, can it get hurt when they go boom? Yeah. It depends of the capacitor, but if it's a big one, they really go boom. I once burnt a resistor. I didn't know it was burnt. I touched it and it left a mark for like 2 weeks. It happens. You find joy in getting hurt sometimes. But yeah, that's how it happens. Cool. Okay, so let's go into the basics. So we have to deal with three things or concepts that we have to be familiar with, and we have to know before diving into Arduino and microcontrollers. The first thing is voltage. Okay, let's see. Cool. So voltage is basically the amount of energy that we can have. Okay, that's basically it. So imagine voltage as in, I don't know, we could imagine a big bowl, a big box full of water. Okay, so you have a lot of water here. This water is not made out of water. For voltage, it would be made out of electrons. Okay, so the bigger the bowl is, the less water we have. Okay, actually, the bigger the bowl, the more water we have, and vice versa. Okay, cool. So this is a battery. Okay, and that's how voltage is stored in a battery. Okay, we can store voltage in a capacitor. It has another case which I won't dive into in the stream, but this is basically voltage. Okay, cool. Now there is another thing called um, amperage, or let's call it amperage. Okay, cool. So basically, this is having your bowl with water full of electrons. Okay, can you zoom in a bit, please? Yes, sure. Can I do this? Oh, I can. Oh, shoot. Let's see. Is that better? Hope that's better. Cool, 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 cool. Nice, thank you. Cool. So, amperage, or the intensity. Okay, let's say that we have our battery, our box, and then we have a little bit of an opening here, and either it can drip a little bit, or we have a big opening that it overflows. Okay, so basically the amperage. Basically, yeah, that's current. Yeah, your current is the flow, or the amount of flow of electrons that you can have in your circuit. Okay, so voltage doesn't do anything to you, current does. Voltage doesn't burn, current does. Okay, so voltage is just electrons, current is let's say, the pressure at which electrons just fly away. Okay, they usually fly away in copper, in cables, resistors, stuff like that. If you put your finger there, it'll probably burn a little bit. Okay, if you have 5 volts, 12 volts, it won't do anything, because the current won't be as high. If you have 120 volts connected to, I don't know, a cable that's short circuited, you touch it, and yeah, that's not gonna be fun. But that's basically amperage or current. Okay, cool. Now voltage, you probably would know, it's measured with a V, which stands for volts. Okay, current with amps or amperes. Okay, yep. And we have a third thing that we wanna know before, which is resistance. So resistance is basically, you can see it with the same analogy as, I don't know, let's just think about, okay, probably my drawing isn't that good. This is like a thing that you can just turn. Okay, when you turn it, when you close it, it's like a valve. When you close it, water will be dripping like this, or if you open it, water will just go like this. The more the resistance, the less current it'll go through. Okay, the less resistance, the more current. Okay, cool, 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 nice. So this is, resistors are measured with omegas or ohms. Okay, so if you see 1K ohm is 1,000 ohms of resistance. Okay, and we'll check that in a second. Okay, cool. Now this is basically what I wanted to first explain. The other things, which are a little bit more of interesting things, is, let's say we have a circuit. Okay, let's say we have a battery, which is usually drawn like this. Okay, it's a circle or a square with plus minus. We have our cable connected to something, which is a resistor. Then we go back and do this. This is just a dummy circuit. Okay, it doesn't do really anything. It just kills the battery, basically. You just drain the battery. But yeah, we usually think, hey, current goes from positive to negative, right? It means it does this. For us engineers, if we work with electronics, we are used to this. So we say always energy flows from positive to negative. Yeah, in theory. In practice, no, it doesn't. In practice, actually, remember that a battery has electrons. Okay, electrons, as you see, they have a minus sign, which is they are minus powered, so to speak, or negatively powered. they are attracted to positive. So what really happens is this. Okay, it doesn't really change anything. It just changes the symbol or how you see stuff. It's basically relative. But I just wanted to share this with you. When you are working with circuits, know that if you take from positive to negative, that's like the theoretical electron flow or current, but it's not the real one. The real one is from negative to positive. Okay, that's how it works. Cool. That's something. If you have this, okay, let me explain something which is a short circuit. Okay, if you have this, meaning a cable, you just get your battery, you connect the cable from positive to negative. Boop. Nothing will probably happen. Your battery will heat up, and after 5 minutes, it doesn't explode. It just like gets big. That's because you're basically short circuiting. Okay, a short circuit means you are connecting both of the poles, positive and negative, without anything in the middle. If you don't have anything in the middle, then there is no flow basically, and voltage just keeps going and going and going, and electrons just keep, you know, going from positive to negative or negative to positive, and you just burn the battery. Okay. If you're working with, if you try to connect, don't do this at home, please. If you try to connect to your socket and then you just connect positive and negative, it'll spark, and all your breakers will go down just because it's a short circuit. Okay. Cool. Just be careful whenever you're doing any any circuits. Add at least a resistor. Okay, at least. If not, then you'll short circuit and that'll go bye-bye. Okay, cool. Now, last two things before we go into Tinkercad. Okay, first thing is a breadboard. Okay, what is a breadboard? We'll see it in a second, but it's basically like this. Okay, let me just do this. Okay, cool. Now, a breadboard has pins. You can connect to the breadboard. 1, 2, 3, 4. 1, 2, 3, 4. Okay. Usually these types of breadboards have like this. Okay, we'll see it in a second. Okay, but what I want you to know is that in this side of the breadboard, anything connected to lines are connected to each other. Okay, so it means like this is a connection of the breadboard. If you connect this dot with this dot, it's a different connection. Okay, it means you're connecting one pin to one and the other pin to the other. It's not in the same row, so it's not short circuiting. Okay, just careful with that because we'll put LEDs. If you put an LED here and here, that's a short circuit. Okay, and it won't do anything. Okay, cool. Now this is for this part of the breadboard. For this part of the breadboard, it works all the way around. It means negatives are like this, positive are like this. Okay, just keep in mind that. Careful when you're connecting stuff. But yeah, again, this part over here, which doesn't have the positive nor the negative, just it's a row connection, and the other one is a column connection. Okay, it happens. You just forget that. Hey, I forgot that it was a row connection. I thought it was a column, and I burned it. It happens. Okay, just careful with that. Cool, 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 cool. Last but not least, actually, Arduino pins. Let's just double check them in Tinkercad. Okay, let's go there. Let's see how this looks. Okay, so let's see. Let me put my Apple Pencil here. That's it. So let's see. Let's open Tinkercad. This is how it looks. Okay, this is Tinkercad. Basically, it's my account. You can create lots of stuff here. You can do 3D designs. You can do circuits and code blocks. Okay, we will dive into circuits. Okay, these are the circuits that I designed for this stream. We're gonna do them from zero. Okay, cool. Now click on create, okay? And then you go to circuits, okay? It'll open a new blank space, okay? Cool. Now, what are these things? Like, how does this work? Well, you have a lot of components here. Here we have the basic components. This is a resistor. This is the thing that I was talking about. If you see, it says kilo ohms, which is 1,000 ohms. Okay, we have 1,000 ohms. We can go that to gigaohms, which is basically kilo mega is a million. It's like a billion, I think. Yeah. Cool. Okay. With a 12-volt battery, this won't do anything. Okay. But this is how a resistor looks in real life. Okay. Cool. Now, if you want to erase stuff with delete, that's it. Cool. Okay. This is our battery. Okay. Here we have the positive and the negative. Let's just short circuit this to create a cable. Just click on positive. You can click here for us to, have like a intersection here. So we do this, we do this, we do this. Okay. So it won't do anything up until we click on start simulation. Okay. We'll do it. Yeah. I don't know if can we track temperature? I'm not sure. Yeah, we can't. Okay, cool. So I don't know if after a while it'll just tell us like, hey, your battery's dead. But if you do this, you'll just drain your battery dumbly. Okay, just don't do it. Cool. Okay, let's just stop the simulation for now. If someone wanted to know if a capacitor explodes, this is a capacitor. Positive. If you wanna how accurate is Tinkercad? I think it's really accurate. Okay. It doesn't have so it's accurate. It doesn't have let's say very very specific behaviors. Okay. So if you wanna I don't know, graph how a MOSFET is acting or something. I don't think you can do that. It's pretty accurate with what it has, which is basic components like potentiometers and all of that, but it stays there. Okay, but again, it's really accurate. Cool. Nice question though. Cool. So if you want to explode a capacitor, don't like if you want to do it, just do it outside of your house. Positive goes to negative, negative goes to positive. 3, 2, 1, explode. Okay. Yeah, it's a simulator. It won't. Nothing will happen. But yeah, they explode. Okay. A lot of smoke comes out of it. Cool. Okay. Nice. So this is a battery. Okay. Now let's go for the holy grail, which is the Arduino. So this is an Arduino board. Okay. This is how it looks. Do I have mine here? I think I do. Yeah, no, it's buried under. No, I won't show it to you like in real life. This is how it looks basically. This is an Arduino Uno. Okay, we have a Mega, we have new Arduinos, but this one works fine. Okay, I think it's the only one, the only one that we have. So we can work with it. You can see here we have pins. Okay, I'll actually zoom in a little bit. We have pins. Okay, important pins. We have 3.3 volts. This thing will always output 3.3 volts. Always, 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 without stop. Same thing with the 5 volts. Here we have grounds, okay, which is if you want to close the circuit, you just close it with ground, okay. You have analogs, which is the input analogs, which is if you want to read temperature or something and it's not digital, you have to add them here or connect them here, because if you connect them here in these rows, then Arduino will just read 0 or 1, won't read analog, which is float basically. It says digital, and we see it has a PWM, and it has like this thingy, and some numbers have it. What does this mean? We won't use it in the stream, but this stands for pulse width modulation. It means you can create a signal to control a motor or something, and you can basically shorten the signal or do it bigger. Yep, so you can control the pulse, and it gives different speeds of motor. Okay, we won't do it just because it'll take a little bit more time to code, but it's really fun to do. Okay, cool. Now this is the board. The real microcontroller is this thing here. Okay, and yeah, how you connect it to your computer is via this ports. When you load the PWMs are only for output. Okay, not for input, because what you're trying to control is the speed of an engine or the speed of a motor. Probably, let's say, basically speeds, but it's always out, never in. Yeah, cool. Nice, good question though. Cool. So when you can connect your Arduino to your computer, you load the script, and then you can connect it instead of your computer. You can connect it um, to the power, and you can, it doesn't have to be connected to your computer always. It says here, how important are PWMs? Like for projects and control motor speed? They're pretty important. Okay. Let's say that you're trying to do a drone. Okay. People do drones with Arduinos. You have to use PWM because you have the drone which has like four motors. Okay, if you want to go forward, it means both of the frontal motors have to have a little bit less speed than the ones that are in the back. Okay, so you can change that speed with PWM. Okay, so it's pretty important just because it allows you to have a little bit more versatility in what you do. Okay, it's not like a 0 1. It's that you can control the zeros and ones. How, like, I can give you 5 seconds of zeros in a second and one. It means you'll be off 5 seconds and you'll be on 1 second. But think of that as in milliseconds, and that'll be really like it just adjusts speed. It says here, why can we use analog pins instead of PWMs? Okay, cool. Analog pins, in this case, are inputs. Okay, we use these to read sensors such as, do we have moisture? Yeah, there we go. Cool. So this is a sensor, okay, that reads moisture. You put it in the water or you put it in soil. That's how they use it. Um, and it basically tells you, hey, it has 0.1 of moisture. It has 0.3. It has 0.02. So it doesn't give you a number like an integer. It gives you a wide range of infinite numbers. Okay, so we cannot use, first of all, analog pins because they're inputs, not outputs. And the second thing is, in the end, engines or motors will not be controlled with the Arduino per se. They will just be fired up. The one that's, and we'll take a look at it in the final project. What controls the motor, it's a battery, not the Arduino, because you can burn your Arduino. Okay, because motors need usually 12 volts, and this Arduino takes like 5 volts out, so you could burn it. Okay, but good question though. We'll take a look at that in a second. Cool. Okay, a little bit of water and nice. So how do you do? How do we use it? Okay, how do we use this thing? So in Tinkercad, if you click on code, you can either code in blocks, like as in Scratch, okay, or we can do the pro way, which is text. Okay, this is how your Arduino environment usually looks like, okay, in real life. So, quick tour. We have two functions that cannot be erased: void setup and void loop. Void loop is a function that will always run on loop. Okay, that's why it's called loop. It'll do this for eternity. Okay, setup is used to say, hey, I want my pin mode. So I want the mode of my pin, LED built in, which is this LED, I think it's this one. Okay, output. Okay, it means you can say, hey, I want pin number 4 to be an input, pin number 5 to be an output, pin number A0 to be an input, pin number 5 to be an output. Okay, that's how you control where you receive and where you give information. Okay, so let's just run this dummy thing and see what happens. See, this thing is blinking. Okay, you can see this little light. It's because it says, hey, I'm writing digitally. It means either 1 or 0 to LED built in, which is this pin over here, which refers to this one. It's high. Okay, it means send a 1. It means turn on. It turns on the LED. It says delay 1,000. It says delay 1 second. Digital write, the same thing but low. Low means 0. It means it doesn't have power. Turn off and wait 1,000. And then the same thing. Turn on, wait a second, turn off, wait a second. Turn on, wait a second, turn off, wait a second. Okay, that's how this works. Okay, now let's just do something a little bit more easy, and then we'll go from there. Okay, so let's just erase this. Get rid of this. Okay, again, don't get rid of the functions. You can get rid of what's inside. Okay, cool. So first things first, every time you code in Arduino, in this case they didn't do it, which is okay, but every time you do it, if you want to see printing statements, if you want to print to the console, you have to do serial dot begin. Was it yeah, begin, and then usually it's 9600. Okay, cool. What does this mean? It means I want you to talk to me in this frequency. Okay, it's basically a frequency that the Arduino will be talking to us. Okay, not to other things, but to us. Okay, cool question. What other programming languages can Arduino be coded in? It's usually C++. I've never seen Python, but I'm guessing you can do it with Python, but in the end, C++ is the one to go, just because it's the built-in one and the fastest one. Okay, cool question though. Nice. Okay, so we wanted to talk to us. Okay, we want to do a hello world. So if we want to print stuff, we do serial dot print line. Let's do hey hackers. Don't forget the semicolon. There we go. If you're used to Python, then you can forget semicolons. It's easy to do. And then we'll wait 1 second. Okay. Usually try to add delays, because if not, you can bug the Arduino. Okay, because it does it pretty fast. Okay. Let's see what happens. Boop. Okay, it says it's on. You can see a little light here. If we go to something called serial monitor, cool. We have something talking to us. It says, hey, hackers. Okay, cool, nice. So Arduino is listening to us. We are reading Arduino. What else can we do with Arduino? So this is something really interesting. So stop simulation. We can do everything that comes to mind. We'll start with a traffic light. Okay, it's an easy thing to do. The best thing is that it allows you to understand how everything has to be connected. Okay, you can move the Arduino with the mouse. Okay, if you press on R, you can rotate your Arduino. Okay, we'll leave the Arduino as it is for now. Cool. So what do we need for a traffic light? We need, well, lights, right? So let's go with LEDs. So LED stands for light emitting diode. Okay, it's a diode that has, or like, can emit light. Okay, cool. Let me just zoom in a little bit here. Let's see. Will I? Yeah, I think we'll use a breadboard. Take a look at breadboards now. Cool. So let's go with the small one. This is the breadboard. Okay, again, remember, you can see actually if you hover over the breadboard, you can see it here. If I put my mouse over here, it tells me that F, G, H, I, and J are all connected to each other. Okay, careful there. It means that if I connect F1 and F2, they won't be internally connected. Okay, cool. Just careful there. Nice, nice, nice. Okay, now, what else? Remember here, the same thing. Rows and minus plus is column. Okay, so this is all connected to each other. These are all connected to each other. If you put your batteries here, we usually do, then just remember to follow the convention of the breadboard. Okay, cool. So how do we connect an LED? So we have an LED. This is the red. Let's get the green and the yellow. Okay, now you can change the color. It says here red. Change it to green. Should have changed it to okay, cool. Yellow, and let's do this. Cool. Now we have our basic setup. Okay. Now, how do we do this? First of all, we add the LEDs. Okay. So remember, not like this. That will short circuit everything. You add it like this. Okay. So we'll add it here. It's connected to this one and this one. Okay. Yellow and green. It's not symmetrical. Give me a second. That looks better. Cool. Okay. Now they're just connected to the breadboard. They don't do really anything. Okay. So what do we need to connect it to the Arduino? Well, let's assign pins. Okay. So let's go to our code. Here, let's just create comments for us to map ourselves. Okay. Let's do red equals 12. Okay. Let's do green. Oh shoot. Green equals 10 and yellow. What's happening to me today? Equals 11. Cool. So this is what we are going to follow. It means the red one, which is here, will go to pin number 12, which is this one. Okay, so let's do that. Let's just take a little bit of a cable here, neatly put it here, here, and it has to go to the cathode. Okay, I'm pretty sure it's the cathode. I always get it wrong the first time. Cathode is the positive, anode is the negative. Okay, cool. As far as I remember, I always get it wrong. We have ground. Okay, so how do we close the circuit? Okay, so we have to close it with ground. Let's just take a black cable. Come on, not that one. Let's do that red. Let's take a black one and close the circuit. Let's add ground here. Okay, so ground will be here. Cool. So now all of this column is ground. So what we'll do, we'll just do this. Okay, it means connect this row, this whole row to this whole column. Okay, same thing here. This LED goes here, this LED goes here. Okay, cool. I hope you don't have any questions, but yeah, that's how it works. Now, this is usually the normal setup. There is a little bit of a mistake here. Resistors. When you are working with electronics, you have to control how much flow of electrons is going to your components. To protect them, we use resistors. Okay, this means that we'll have to have our LEDs like this. We'll remove this one. We'll add a resistor here. Okay, so these rows are connected, but you see a breach here. It means that these rows are not connected to each other. Okay, so we'll add it to the cathode. Cathode is protected by a resistor, and then we'll just take the cable out to 12. Okay, it means going like this, doing like this, this, and this. Voila. Okay, cool. It means that electrons will flow this way, meet the resistor. The resistor goes like here. It turns on the LED and it closes the circuit. If it's all the way around, it does the same thing because in the end, it's not where it's located, but it has to be located. Okay, it could be here or here. Okay, it doesn't really matter just because it's closing the circuit. Okay, cool, nice. Same thing here. Let's copy this thing. Cool, 1 and 2. Okay, so yellow, remember what was yellow? Yellow is in 11 and green is in 10. So yellow 11, which is here. Let's do it like this. That looks horrible. Shoot. There you go, like this, like this, like this. Okay, cool, that looks neat. And we can do green with the green. So let's take a green cable. Green was in 10, right? Yes. So let's take it to here. Okay, and then we'll just prettify this. Don't you worry, cables won't connect with each other. Okay, so the simulator just knows how it works. Okay, cool. Now we have how it looks here. So if we activate 12, 12 will send a 5-volt signal to a resistor. Resistor filters out some of the flow, goes to LED. LED turns on. It turns on because it's closed circuit with our ground. Okay, ground is here. Okay, cool. Now, Let's code. Okay, that's all the hardware that we need. Let us code. Oh, shoot. Yeah, it won't do anything. Yeah, cool. Yeah. Sorry, misclick there. Okay, cool. So we have the serial begin. Now, remember that we had to set up the pins, either input or output. So that's what we will do. So set up pin. Cool. So we do pin mode, which is a built-in function. Inside, we'll put 12, which is the red one. Okay. And we have to do output. Cool. This means we set the mode of pin number 12, the red one, as an output. Okay. It won't be receiving any signals. It will be sharing signals. Okay. Same thing with 11 and 10. Okay. Should be 11 output and pin mode 10 output. Okay, cool. Now we have the pin set up. It means Arduino knows 12, 11, and 10 will be sending signals out. Okay. Now, what do we do next? We can do other functions. Okay. As long as we respect these two, we can create as many functions as we want. Okay. Cool. Now, we'll have a function that's called red light. Then we'll have to do green. And then we'll have to do yellow. As it usually goes, first is red, then you can start to move your car. In green, it takes 5 seconds. And then with yellow, blink twice, 3 times, and then go to red again. Okay, again, because it is a loop, it'll do this, this, and this, and go back. Okay, cool, nice. So, can I zoom in? Yeah, probably that looks better. Cool. Nice. So let's create the function. Okay. If you've written C++, you know about this. If not, then void means this function doesn't actually return anything. Okay, it just do something. So void red, was it red left? Just copy paste because I know myself. I know I'll get it wrong at the first time. It always happens. There you go. So let's just prettify this, saying function that controls the red LED. Why is there no music? I just realized that. What? Wait a second. Yeah, I'm sorry about that. There we go. Cool. That's way better. Nice. Okay. So we have the function that controls the red light. Okay. So this means this goes after yellow. Okay. Then whatever happens, we should turn off yellow. Okay. You can send signals, zeros or 1 with digital right. Okay. Again, digital is either 0 or 1. You cannot have any other numbers. Okay. So digital right will do yellow, which is 11. Okay. And we'll do low in capital. Okay. This means turn off yellow. Okay. Cool. Just in case. Nice. And then we do digital right. Red is 12. High. Okay. This means turn off yellow, turn on red. And then we do delay. Let's do 5 seconds, okay? Again, this is in milliseconds, so 5,000 milliseconds is 5 seconds. Cool. That's it. Okay, let's go with green. Again, void, because this function doesn't really return anything. Green LED. Same thing, let's just prettify it. It says function that controls the green LED. Okay, this is basically the same thing. If we have red turned on, then what we should do is turn it off, right? 12, which is red. Cool. Red is now turned off. Let's turn on green. Green was 10. Cool. And then again, delay. Let's give people 5 seconds to move. Okay, cool. Red and green are the same. Okay, they just do the same. Now, after green, we'll get. Wait a second. Am I just getting it right? Yeah, I think the one that blinks is green. Let's just do yellow that blinks. Okay, why? Because I got it wrong. But yeah, it's just the same logic. Okay. I just thought of it now. I was like, why would yellow blink? It's usually red. I'm sorry, green that blinks. But if it works, cool. Void. Let's do yellow. LED. Same thing. Function that controls the yellow LED. Okay, now we got green on. First things first, turn off green. Digital right should be 10, which is green. Low, which is 0, which is turn off. Okay. Now, what should we do? Now, int is for an integer. Okay, we want to count how many times yellow has blinked. Okay, so we do is on equals 0. Okay, now we'll do this. And 4 int I equals 0. I is less than or equal to, let's do 4. Okay, so we'll blink 4 times. Okay, so let's just count 4 times. I plus this. Okay, cool. Now, what should we do? So, if is on double equals 0, it means if it's off, then what we should do is digital right 11, which was yellow, and then we'll do high. Okay, so again, this is a flag that tells us, hey, either it's on or off. Okay, in this case it means it's off. Okay, just in case, let's do it like that. And then the flag has to be flagged. Okay, so shoot, it just looks horrible if you don't. There we go. Is on now equals 1. Okay, now we turn it on. It's on now. Else, shoot, sorry, Python there. Digital right 11, and we should turn it off. Okay, which is low. There we go. And is on equals 0. Okay, it means if it's off, turn it on and tell me it's on. If it's on, turn it off and tell me it's off. Okay, and this will be delayed let's do half a second. Okay, so it's not, the blinking is not that fast, but not that slow. Okay, cool. Now let's just read it, skim it quickly. We have in loop, which is the function that reiterates once, twice, up until infinity. These 3 things. We will go from red to green and then to yellow. This is yellow LED, right? Yellow LED, yeah. Cool. Okay. We have red. We start with red. Turn off yellow because after yellow comes red. So whenever the loop is off, guys, for yellow, we do digital right 10 low, which is turn off green. We have a flag that tells us, hey, is yellow on or off? If it's off, then turn it on, and we have a flag. If not, then we just update the flag, and that's it. Okay, cool. Let's see this in action. 3, 2, 1. I hope I got the terminals good. No. Cool. You'll say, hey, it doesn't work. Yeah, it doesn't. You know why? Because it's not like this. Okay, cool. So let's mirror this. Okay, so it looks like this. Is it like that? Yeah, there we go. Yeah, okay. So anode is positive, cathode is negative. Okay, I always get them wrong at the first time. How many times have I got this wrong? Like 6 years, 7 years that I've been working with LEDs, I always get it wrong. Why? It just, I don't know. That's me. Cool. So rotate them using this mirror thingy. So it should, like, the anode should be in the positive, the cathode in negative. Okay, 3, 2, 1. Now let's see how it works. So you can see LED is turned on. Okay, let me just zoom it in. There we go. LED green is turned on. LED red is turned off. We can see a blinking there, and we get green, and I'm sorry, yellow, and then red, and then green. There we go. Cool. Now, you might say, hey, what happens? What would happen if I do this? Okay, let's just connect this like this without a resistor. Okay. It tells you current through LED is 53.5 milliamps. Okay, it means it's a lot of current for an LED, and as you can see, the LED will turn on brighter than the others. Okay, if you want to control brightness to an LED, you have to use resistors. But careful, if you don't use any resistors, this LED, it says lifetime of the LED might be reduced. Okay, careful with that. Okay, that's why we add a resistor. If you want it brighter, then we just change, instead of how can we change? What? There we go. Instead of 1 kilo ohm, let's just do half of it. Okay, 500 ohms. Okay, same thing here. 500 ohms, and same thing here. Ohms. 3, 2, 1, and we'll see that it's a little bit brighter. Okay, that's how you control brightness. In the end, this LED, it's a small LED, and we don't expect it to light up the whole world. Okay, it's just how it is. Okay, a bigger LED will require a different resistance, and therefore will just light up differently. Okay, cool. That's how it goes. Okay, that's how it works. Now, nice. First project worked like a charm. Okay, cool. Now, we use breadboards because if we all do it floating in the air, one is not realistic. You will never have stuff like that. If you do stuff like that, it's, you can just burn stuff. It's easier to debug because debugging hardware is sometimes a little bit difficult. You have to map everything in order. Okay, we know that the red one is the red. Okay. Can you say that again? I'm not sure. What happened here? Okay, base viewers on streambo.com. Remove the space. Okay, cool. Nice. So, this little button here, if we start a simulation, this little button resets the whole thing. Okay, let's wait for it to go green. If I click it, it goes to red. Okay, this button resets everything. Okay, if you need a reset, let's wait for it to go to yellow. It should blink. If I click on reset, 3, 2, 1, shoot. There we go. Cool. It went to red. Okay. This helps you to reset. Okay. Cool. Nice. So, our final project is going to be something similar to a robot. Okay. A robot that will move based on its surroundings. Okay. How could you check your surroundings with Arduino? So you have a lot of things that you can use. Something that is very typical is the use of this thing. This thing is an ultrasonic distance sensor. What it does, it basically works like a bat. It sends ultrasonic frequencies, they hit something, and then they go back. It does a little equation there, which is like start time minus end time. and it gives you a distance. Okay, we'll actually have to code that distance, I guess. Yeah, I think we have. But yeah, so that's how it'll work. Okay, this thing works in analog. Okay, as well. So we'll see how analog works. Okay, cool. Let's just clean our setup pretty fast. Ah, shoot. Okay, cool. No worries. We'll just take a breadboard, put it here. Okay, cool. Now we have this. Now, how does this work? You can see we have different pins here. We have 4. GND, it goes to GND, okay? It means it's your ground. VCC is your power, okay? It means this has to go to your 5 volts, okay? How do you know it's 5 volts? Ah, easy. If you go here and then you do ultrasonic sensor datasheet, click on images, click on the first one that you see, it says VCC 5 volts. Okay, if you are doubtful about something, go check the datasheet, okay? Datasheets looks like this. In the end, you can see it here. It doesn't say anything, so you see here, 5 volts, okay? Cool. Now, we know that this one has to go to 5 volts. Let's put it like this, so it's a little bit easier to use. Black goes to ground. Let's put ground here as last time. And let's do red for VCC. Shoot, okay. I know it looks horrible. Wait a second. I guess here. We can do it here too. Yeah. There we go. God. Cool. I'm sorry. It's just, if it's not that neat, I don't like it. Okay, cool. Now, we have to first turn it on. Red is 5 volts, okay? So let's get the 5 volts out. Let's put it here. 5 volts here. And black for ground. Remember that we have a ground here, so we can do this. It's a little bit easier, okay? Cool. Now let me just do this so it doesn't look weird. Can I move the Arduino, please? Okay, that's okay. Cool. Now that we have connected everything, let's see how this works. So we will connect trigger to 13. Okay, so let's do trigger is, oh, let's do green. Let's put it where? Yeah, let's put it here. Why not? Cool. We have trigger there, and we will have echo, or probably not. Probably, wait a second. I think we don't need any breadboards here. Why? Because we'll just use one, so it doesn't look neat. Okay, let's just do this. I'm sorry. I think it looks better. So we don't have that much noise. Ground to ground. Okay, that's the same. And red to VCC, which would be here, here, and then 5 volts. Okay. Let's just neatly put this here. There we go. Now, trigger is going to be green. Echo is the one that goes to analog. Okay. We'll put it to A0. Okay. Give me a second. It just looks neat. There we go. And with blue, we'll just do trigger. Okay. Trigger is going to be, let's do 13. It's the same. Okay. It needs to be digital, but you know, any number is good. Cool. Okay, so if we start the simulation, it won't do anything. It probably has an LED here. No, it doesn't have. Okay, cool. It doesn't do anything. Cool. Let's code it. Nice. So void setup out, void loop out, and the rest goes out. Nice. So we will code something like an alarm. Okay, so first things first is alarm. Okay, cool. Now we will have to define pins. Cool. So first pin first, analog. So it's pin mode. Okay, careful with the capital M. A0, as the name is, so it's called A0. So A0, that's how it recognizes it. And it's input. Okay. What does this mean? That whatever the sensor reads, it'll output it to A0. Okay, because it will read distance. Then distance is a float. It's not an int. It's not 0 or 1. It's just an int. Okay, cool. And then we have the trigger, which is pin mode 13, and then output. There we go. Nice. Okay, so there we go. That's trigger. So what does trigger do? So trigger will listen to whenever we send a signal for it to read. Okay, so hey, trigger, read now. Trigger will output an ultrasonic wave. It'll come back and echo will listen to it. Okay, that's how it works. So let's see. Let's have a function that returns a long. A long number is not an integer. It's way bigger than an integer. Okay, let's call it read. Okay, cool. Now let's just do the same thing. Read ultrasonic sensor. There we go. Cool. Now, cool. Wait a second. Let's just map here. I'm looking at my code. So, echo. It's A0. Green is. We don't have either green or this one. So, trigger is 13. Okay, and we will have, let's just turn off our built-in LED. Okay, remember the code last time? It was pin mode LED. Was it with built-in? I think it was with capitals. This is output. Okay, cool. So we will turn this LED on, so we don't have to add more LEDs. Okay, so it'll turn on when something is really close. Okay, cool. So we have the read function. The read function tells me like, hey, let's send something to the trigger pin. Our trigger pin is 13. So 13, and then send a high. Okay. Oh, actually, let's clean it up first. If you don't clean it up, sometimes it just bugs a little bit. So careful with that. You can either do it or not. I usually do it, but you know, if you don't do it, it can bug. Okay, just careful there. Okay, cool. Let's just delay microseconds, so it doesn't take too much time. Microseconds. 2. It won't take anything. Okay, cool. Now we'll start reading. Okay, so digital write. It's trigger pin. High. Okay, cool. Now it'll delay it because it's sound wave. It's pretty fast. So delay microseconds. 10. Cool. And then we'll turn it off. Okay. 13 low. Okay, there we go. Once that we read we return the, wait a second, why do I have, yeah, okay, yeah, okay, so we return false in. It's A0. Okay, okay, cool. So in the end, it's going to return, I think I have a mistake in my, yeah, it should return, it shouldn't return this. What? It should return A0. Okay, I think that's how it works. Because in the end, we'll return what the echo listens to. Okay, cool. Now, void alarm. Okay, so this alarm function that will control the alarm. Okay, and then we have long read ultra equals read. Okay, so we have to read first the ultrasonic sensor, and then serial.print ln. Let's just print sensor value is, and then serial.print line. Let's do read. Okay, whatever we read, we'll print it, and then if read. Oh, you know, that's what happens when you do a lot of Python. Okay, you forget that you have to add the parentheses before. Read is less than, let's do 3500. It's just a number. Okay, with the robot we'll take a look at the equation of actually calculating the distance. Okay, but let's just do it like this for now. Let's do digital write LED built-in. Hi. Cool. Else. And let's do digital write. So we turn it off. Okay. It means whenever something's really close, turn it on. If it's not close, turn it off. Okay. I feel like this doesn't look that good. Can I do large? Yeah, let's do that. Cool. Digital write, and it should be LED built-in. Low. Cool. And semicolon. Okay. Now there is something that's bugging me, which is this line over here. Hopefully it'll work. Ah, there you go. Function long in red error arguments function long assign. Okay, now declare here. Wait a second. Delay was it delay microseconds? Wait a second. Delay microseconds. Okay, that's not good. When you see a lot of reds, that's not good. Hold on. Okay, let's go scroll down. Let's see what happened. Too few arguments to function. What? Why? What if I do this? Let's just not use this one. Let's see what it works. 1, 2. Let's see what happens with that. Okay, yeah, that's the error. Focus on main end, many arguments. Yeah, return. What if I do this? This is the part that was bugging me a little bit. What? I just said get out of here. Cool. Ah, nice. What? Is it this? Wait a second. What's happening here? Okay, function void alarm. No matching functions for call print ln. What? Print? Is it? Did I? Serial dot. This is the same, right? Shoot. Should be the same. I think I'm guessing what's happening. Okay, well that's not good. Give me a second. Let's see what's happening here. We cannot print longs. What? But I tried this before. What? This is alarm is, yeah, read, yeah. Read, ah, got it. It's read ultra. Sorry about that. It happens. It always happens. There we go. Ah, cool. Now, if read ultra. Come on. Okay, yeah, there we go. No errors. Cool. Now, serial monitor. Sensor value is, we have a value, okay? So you can see we are reading the value. How does this work with Tinkercad? You click on this. You see, we have a little ball here. If we approach it, see? And we said under 5,000. Did I just mistype LED built-in? Wait a second, because this one. What? Serial dot print ln. I'm here. Let's debug together. Let's see what's happening. Okay, I'm here. Then why are you not turning on the LED? What? Wait a second. LED built-in Arduino. Did I just mistype a LED built-in? LED built-in. Yeah, it's fine. Yeah. Why? What's happening? Let's just use Arduino docs. Is there a pin connected to? Ah, great. That's just great. We're using 13 as trigger. Shoot. Okay. Let's just. Cool. Let's just do this. Okay. Let's see what we can do. Let's go to 12. Okay. So what I got here that I didn't know is it seems that pin 13 is also LED built-in, which is kind of weird. I'll just try to see if 12 works, okay? 12 means that 12, and yeah, that should be it. Let's see what's happening. Yeah, there we go. See? Okay, cool. Let's just stop here. Remove this. I don't want to look at the serial monitor. Okay, cool. Now, our alarm works now, okay? Let's just take a look at it. Code out. You see the LED turned on, okay? What if this is way here? Ah, it turned off, okay? So we are checking this, like the proximity of an object based on whatever this thing is reading, okay? So you can see the LED built-in, which is this LED here, okay, this one here, won't turn on up until we have, ooh, where is it? This one or this object closer that we want. Probably closer. See, there we go. The LED is turned on. Okay, that's an alarm. Okay, now we can leverage this in different ways. We can leverage this in different ways, okay? First thing is that whatever we do, we can read distance, and based on the distance, we can do other stuff, okay? We can either go back, we can either go forward, turn, print to the user, have an alarm with sound, I don't know. You can do lots of things with this. For our robot that we are going to do, our sensor is going to tell us, hey, there is something in front in the right part, turn right. I'm sorry, turn left. If it's in the left part, we'll turn right, okay? You know, it'll be as simple as that, okay? We won't be using PWM just because I don't want to deal with the code right now. But yeah, like ideally, the robot should be working as a Roomba, which is I'm cleaning, I'm going forward, and then I see a wall, I just slow down a bit, and then I turn. Okay, that will be the ideal one because it's just an introduction to Arduino. I don't want to get into pulse width modulation, so let's just leave it with on and off. Okay, cool. I hope you don't have any other questions. Let's start with the robot. Okay, cool. Now, this one is going to be really interesting, okay? A lot of code, like 100 lines of code, but we can do it. So, come on. What? There you go. RRR. Okay, cool. This Arduino is kind of like bugged, right? Can't move it. Yeah. Yeah, okay. Cool. Now, Arduino. There we go. Let's just put it this way over here, like this. Okay? Cool. Now, for this, we will need something which is called a transistor. Okay? Actually, it's not a transistor. It's a it's called a trigger. Okay, and what it does, okay, let me just take out my cheat sheet. Wait a second, Tinkercad, there we go. Can I have two at the same time? Yeah, because I want to see this, because I don't remember how this was. Proceed. Proceed anyway, yeah, that's okay. Okay, cool. So remember what I told you, that whenever you're controlling motors, you won't be controlling them with the Arduino per se. Like, it wouldn't, like, the energy won't come from the Arduino, it'll come from a battery, okay? And we need something called a relay, okay? A relay is something that whenever it receives a certain amount of voltage, it turns on. When it turns on, it connects another cable and it'll connect our engine, okay? That's how it works. I'll show it to you in a second, okay? So Arduino has its own relays that look like this. Relay Arduino. This is how it looks, okay? It's a programmable relay. You connect it here, and you just program it as you would normally, okay? In this case, this is the relay, okay? We wouldn't have a relay with a board, okay? So in this case, we will just be using the whole relay, which is this thing, okay? This is how it looks. So see, we have a coil here. This is a coil. This is the symbol of a coil. Whenever here and here we have energy, these two cables here will connect to these two over here. It means we get 5 volts as a trigger, and then with a battery we can power these terminals up to 30 volts, okay? If we do not use this, if we use the Arduino, one, the motor will be really slow, and two, you can burn the Arduino. How do I know that? Because I've burned lots of them until I realized I had to use a relay. Okay, cool. Now we will be using a relay, okay? We have to use 2, okay? So let's just build first everything. I know some things will look weird, but trust me, okay? Now, I try to do it with a battery. For some reason, it doesn't work in Tinkercad, so I'll use something called a power supply, okay? There we go. So a power supply is basically like a battery, but it's programmable, so to speak. You can move stuff to have a little bit more voltage or less, okay? Cool. Now, these things have to go here. Okay, so remember, this is our trigger. Okay, this means that whenever we get energy from here and here, these two should have energy for them to connect here. Okay, that's what we will do. So positive, we get red. Cool. Now, like this, and like this. Cool. Now, that's how it'll work. You'd say, hey, it's easy. You connect the blue or the negative to this part over here. That's what usually happens. When you're working with motors, you have to have everything in the same ground, okay? This means we have to put Arduino's ground, the relay's ground, this power supply's ground in the same position, okay? It means everyone will be interconnected. Nothing will happen, nothing bad will happen. The good thing is everyone will talk or speak the same language, so to speak. If you don't do that, then 0 for someone is 2 volts for someone else. Okay, that's what happens. So in order to not have that problem, we have to bridge all of the grounds together. Okay, cool. Now, to do that, we'll take a breadboard. Okay, breadboard. I like the small one here just because it's not that big. Cool. Take the negative and put it here. Okay, let's do this. Cool. Okay, now this means Arduino's negative should also be here. Okay, remember that these aren't connected per se, so we have to connect them with a cable. Okay, cool. Now we have it there. Okay, ground connected to the other negative, and then we can connect this negative here to this ground over here. It means the circuit is now really closed. Whenever the Arduino talks to the engine or to the motor, it'll listen. It will listen the same 5 volts, not 4, not 2, 5, because they're all connected together. Okay, cool. Now, we have to do a motor here, okay? We have this one, which is the hobby gear motor. It has gears inside. It means if you don't put a gear inside of a motor, then it'll just turn really fast. But with gears, you can control the speed and also control the direction. Okay, so we have this. How do we connect these two? It's easy. Positive goes to positive. Okay, remember, whenever we get the trigger from these two terminals, what we want is for these terminals here to send out 20 volts or 12 volts. Okay, so let's do this, 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 and this. Okay, so these are the outputs, 1, and the black is negative, so let's do 2 here, okay? I know, cables are just a mess. Usually cables are a mess, but that's how it works. Cool, okay, so let's see, that's how it goes. Okay, this looks horrible. There we go. Cool. Now, what are we going to connect to either open or close the relay? Let's just connect it to 10, okay? So let's just take a color, green, connect this to 10, okay? Cool. Remember, if this is positive, then the other one should be negative. If it's negative, then we have to bridge it to the bridge that we have here, which is going to be this. Okay, so all of the negatives will be connected to each other, not the positives. If not, you'll burn your Arduino, because you'll connect 12 volts with 5 volts, and that's going to destroy it. So that's how it'll work, okay? This is the architecture of one of the motors. Let's do the same thing for the other. I'll do it a little bit faster, just so we have time to code it, okay? We'll take a motor out, we'll take a relay out, there we go, and I need a power supply. Dude, my typing skills today are not good at all. There we go. So let's do the same thing, basically. So 1, 2, 3, this should be like this, okay? Cool, so this is positive. Let's go negative first. Negative goes to negative, remember, which is our bridge of grounds, okay? Cool. Positive to basically positive, which is this one over here. A common question might be, how do you know it has to be this one and not this one? It could be both of them. In the end, what you'll see is that these two are interconnected. So these two are normally closed. It means there is always going to be energy. These two from the end, you see the drawing here? These two from the end are going to be always open up until we send a signal. Okay, that's what's going to be. Okay, so that's how I know. Okay, cool. So let's see, let's do it symmetrically, just so it's not that bad. There we go. Positive with red to either one of them. Engines or motors don't have polarity, okay? Either they go forward or backward, but you cannot burn them. Like if you just connect them all the way around, they go backwards instead of forwards, okay? Cool. So let's see if this works as I want it to work. Cool. And negative should be where? In our bridge. Cool. 1, 2, 3, 4. Let's just do this. Why did I do that? I'm not sure. I probably should have left it like this. Yeah, cool. Okay, nice. And the negative here. No, this is not the negative here. The negative here should be here. because in the end, it's already bridged. So we do this, voila, okay? Motor is connected, this is connected now. This is negative, negative will go to ground. If you see, we have here another ground, so let's just use this one. It's the same board, so it's already bridged. Okay, cool. And this one will be turquoise. Shoot, not that one. This one. There you go. We'll just add a turquoise one, which will go to 9, probably. Yeah, let's bridge it to 9. Okay, so let's take this, like this, like this, and like this. Cool. Okay, so what will trigger the left side? I'm sorry, the right side is 9, left side is 10. Okay, so let's start kind of working on that. Text, yes. Okay, so let's do int right motor right m probably equals, what was it? Right was 9, yeah, and int left m equals 10. Cool. So now we are mapping everything. Try to always do it like this, because if not, then you'll have to go back and take a look at every single pin. Okay, actually I'll just change this to green because we'll have more cables, so we know greens are our relays. Okay, cool. Now that's our code. Okay, that's for now. Okay, now what else do we want from here? So we wanted to control these things based on the proximity sensors. Okay, so let's take 2 out. Sensor 1 and 2. Okay, as in 2 eyes, let's put them here. Okay, like this. Cool. So we have to have in the positive part 5 volts. Okay, this means we need from here our 5 volts. Put them, yeah, let's just extend the cable here. There we go. One, bridge it to this part over here. Cool. So we have 5 volts in both of them. Remember, VCC stands for, or what we want is 5 volts. Okay, so 5 volts here. We can do it like this. Okay, it's on. Ground should be black. Oh, come on. There we go. Now this should be red. Cool. Now give me a black cable. Yeah, cool. And the ground should be this. Okay, so they have power. Okay, so they are with a lot of power. Let's connect echo and trigger. Okay, remember that echo has to be analog. Okay, in this case, I think we can use it also with digital. It's not going to affect in anything. Probably it won't be as exact as with analog, but we can use it in digital. Okay, and this is an example. So let's do it. Let's see. Purple. Purple for triggers. Triggers are going to be, let's see, let me follow my cheat sheet. Triggers are going to be 7 and 6. Okay, so 7, 7 for the left part and 6 for the right part. Okay, we'll write it in a second. Cool. So let's do int left trigger equals left was 7 and right trigger is 6. Okay, cool. Now echoes will be, in this case, digital. Okay, let's see how they react when they're connected to digital. Okay, cool. Now let's do it with blue. They were connected to Wait a second. Where's my echo? Yeah, it's 5 and 4. Okay, cool. Let's do left one will be 5, okay? And right one will be 4. So 4 here. There we go. Nice. So let's just write it down. Int left echo equals 5, right? Yep, 5. And int right echo equals 4. There we go. Okay, now, cool. Now that we have this, let's code. Cool. So let's not lose sight of our hardware. Let's not do this. And let's not use these two here. There we go. So first things first, serial dot begin 9600. There we go. Now let's just assign the setup of the outputs. Okay, so outputs are going to be here. So pin mode root, this is left M output, pin mode right motor output. Cool. Now let's do pin mode left trigger output. We can do pin mode right trigger cool. And I think that's it for outputs. Now let's do inputs. Pin mode left echo. Root and pin mode right echo. And there we go. Double space there. I don't know why. There we go. Is that one space? What? Okay, cool. Now, all of the pins have been set. Let's create functions to see. Okay, so we have our sensors. Each of them has to have its own sensing or seeing function. Okay, because both of them will react differently. Okay, cool. So let's do yeah, let's do a bool. Bool C right. For whoever doesn't know what a bool is, it's either true or false. Okay, cool. C right. Cool. Function to see in the right direction. Cool. Now, what we did last time, digital right. We send something to the trigger. This is right, so we have to see right trigger, and it has to be high. Okay. Oh, come on. There we go. And now delay microseconds. Now let's do 2. Now let's do 10. Cool. And then digital right trigger load. Okay, cool. Now we get the same thing. In this case, what we get is a time. Okay, so we will do the math for it to give us exactly where it is. Okay, duration equals pulse n, which is give me the pulse of right echo, and this has to be as high. Okay, Cool. Now, let's do the math. Let's have the float, distance equals duration time. This is an equation over 2. This connects it to centimeters, okay? So we'll give us everything in centimeters. Now, we want to see if something is half a meter in front of us, okay? It means 50 centimeters. So return distance is less than or equals to, okay, cool. Cool, nice. Same thing for the left part, okay? Let's do it. Cool. C should be left. Okay, and then I don't know, function to see in the left direction. Direction. What? Direction. There we go. Cool. Digital right. Should be left trigger. High. Okay. Now again, delay microseconds. We should be getting probably 10 microseconds. And turn it off. Okay. Digital right. Left trigger. Oh, come on. Left trigger. Was it trick? Yeah, trick. Low. There we go. Cool. Now with this, we do the same thing. Long distance equals pulse in. Left echo. High. Okay, so we expect a high. Float this. This is duration. I'm sorry. Equals duration times 0.034 over 2 semicolon. There we go. And we return the same thing. Return distance is less than or equals to 50.0. Okay. Cool. This will give us the distance. Okay. If it's either 50 centimeters away, less or more. Okay. If it's closer, it's a true. If it's a longer, then it's a false. Okay. Cool. Nice. Let's go to the loop. Let's first see. Okay. So to see. Yeah, let me just copy paste it like this because I know myself. There you go. See right, and we should be bool right object. Okay. That's how we do it. Bool left object equals the left. Cool. Now that we see stuff, either we have them close or not, then let's double check. If left object, oh, come on, object double equals true, then this is what we're going to do. Okay. We're going straight. We see something in the left part. What we will do, because we have 50 centimeters of range, we will turn to the right part by stopping right motor and going full throttle in left motor. Okay, makes sense? So we stop this one, we make this one move, and it goes like this. Same thing with the other part. If we see something in the right, then we stop left motor and right goes all the way up there. Okay, so we are moving the robot. Now, this is not the best approach. The best approach, hey, thank you. The best approach is if you see something to turn, put one motor go back and one motor in front, so it moves in its own axis. Because of this relay, we cannot do it. Okay, we have to add another relay, and I think it'll take more time, and it won't be that cool. So let's just leave it as stopping, and then just moving one motor for, turning. Okay, cool. That's the approach. So, stop motor to turn. Again, what's happening with my typing today? What? Digital right. Let's do right motor, right M, right? Yeah, right M, low. Okay, cool. So we stop right, but left keeps on moving, so we go left. Okay, cool. Else if right object double equals true, and then we do the same thing, but all the way around. Stop left motor to turn. Digital right should be left M, low. Cool. Now, if we don't see anything either in the left or right side, then go forward, okay? It means both of the engines or motors go forward. Should be digital right, left M, I, and same thing here, digital right M. Cool. Okay. And yeah, that should be it. We will give it a delay. I tried it with 1 second. It's not the optimal time, just because in 1 second then you can lose data. But yeah, cool. That should be it. 67 lines of code, but that should be it. Okay, so let's kind of read it first, and then see how it reacts. Okay, so we have modes of left motor, left trigger, and right trigger as outputs. Left echo, right echo, which are already declared all here in inputs. Okay, cool. Now we did this so that we can map ourselves. We have a lot of cables here, so use colors to your advantage. Okay, and it'll be easier for you to track outputs and inputs. So we see right, we send something, a pulse to the trigger. Microseconds, we made 10 microseconds, and then turn it off. You got a duration. From that, we do some math, so it gives us an amount of centimeters that something will be in front of us. Okay, cool. Now, and same thing for C left. If we see something left, then stop right and full power in left, so we can turn and just don't hit that obstacle. Okay, same thing for right. If we see something in the right, then stop left and go full power in the right. Okay, if we see nothing, just go forward. Okay, errors will arise. I know I'll have errors. I'm pretty sure it's in the hardware, but let's see what happens. Cool. Okay, nice. So we can see here that we don't have voltage. Okay, this means that we have to move it here. Oh, we probably won't. Wait a second, what's happened? It has to do with the hardware. Let me just double check. I knew it had to happen. 9 and 10. Did I do it correctly? Yeah, you go to there. You're going to GND, which is fine. Motors are not moving. Ah, there we go. Cool. Sorry. Let's do 12 volts here. Let's do 12 volts. No. This one's not working. Why? I'm not sure. I think I have a short circuit in some place. Let's see. Nope. This is positive? Yes. Am I using this positive? Yes. Let's see. Positive goes here, negative goes there. Yep. Positive goes here. Ah, gotcha. Really? Huh, okay, this is interesting. Wait a second, I got it. This is interesting. We do this. This. So why is that? Okay, if it works, then I'll explain it to you in a second. I didn't think Tinkercad will take into account this. Let's see if we do it, what happens. See, there we go. If it works, I'll explain it to you in a second. Ah, there we go. Okay, cool. Now, ignore this Arduino thingy. It's saying it exceeds the current amount. Okay, don't you worry about it. Okay, cool. Now, what's happening here? Why is this not working? 1 and 2. Okay, cool. So we can see this one is turning. Okay, this one is not. Ah, great. Look at this. Instead of closing the circuit, I just left it open. So this one has to go. Yeah, wait a second. No, that was okay. I didn't close the circuit. It means I didn't add ground in this part over here. My mistake. I knew it had to be hardware. Cool. Let's see. Nope, still nothing, right? Oh, let's see. Because this is already moving. Should I move something here? Nope. Wait a second. Let me just debug this pretty quick. This is moving, which is fine. Let me just debug this one first. If we have something in front, then this one should be stopping. So this should stop the engine. It doesn't. Oh, cool. Nothing better than when it actually works. Wait a second. So this ground over here should be the same ground. That's no problem. 10 and 9. Did we get them correctly? 10 and 9. Okay. What else could it be? This is connected to ground. That is connected to ground. That's connected to ground. I mean, this one is ground. This one is ground. Well, that's interesting. 9 and 10. Is it connected positively? Yes. Negatively? Yes. Something's floated, okay? Something is not being connected to. Should I close should I close it here? Let's just try this. Nope. Wait a second, I know why. Probably? No? Yeah. See? This works. If we do this, which one was it? This one or this one? Yeah, there we go. It's at 27 centimeters, the object. This one stopped. Theoretically, this one should be going forward, okay? Now, why this is not happening, I'm not sure. This is not relevant. Is it connected? Yeah. Did I connect it? Yeah. Well, that's not good. It has to be something that I just misconnect. It happens all the time. No. This goes here. Negative goes there. Negative, positive. This goes there. This goes there. Okay, cool. Now, let's do something else, which is I'll show you the one that actually works, okay? Which should be the same. But, okay, so it's the same, okay? I just added 2 LEDs when I created this sketch. But yeah, basically it does the same thing. I'm pretty sure I connected something incorrectly, but let's see it. So same thing here. Both of them are going at a speed. Why is the speed different? See, the voltage is different. 11 here and, oh, come on. And 7. So let's put both of them. Can I put them in 12? Yeah. 12. Okay, 12 volts here and 12 volts here. Cool. You can see that both of them are going at 408 revolutions per minute. Okay. What happens? You can see that both of the LEDs that we didn't add because I thought we didn't have time, but both of the LEDs are turning on. It means nothing is in front. What happens if I do this? Ooh, right LED turned off. This motor turned off. It means it's going to go like this. Okay, it's going to turn to the right side. I'm sorry, to the left side. So right has to be turned on, left is turned off, and it goes like that. The best approach again is having this motor over here, instead of stopping, going backwards. We cannot do it with this relay. We have to do it with another one that's non-existent, sadly, here. Why? I don't know. Hashtag Tinkercad, please do something about it. But yeah, that relay that we saw some minutes ago, which is this one, it has a board over it. Let's just take a look at it again. You can control with this. You can control the speed, okay, and also the direction, okay. The best way to do it is with something called an H bridge. So the H bridge is basically this. You can control two motors with one H bridge, and you can also control their direction. Okay, so that's the best one. Neither of them are in here. Okay, for some reason. Okay, so it has the option, but we don't have an H bridge, sadly. Okay, so that's the best way to do it. If you don't have an H bridge, then definitely use a relay. Okay, because if not, then you'll just break the whole Arduino. Okay, let's just try it here. So we have nothing in here, but what if we have something here? So this motor stops, this one keeps going. It means it's going to go in this direction over here until we see nothing here, okay? And you can see the LED is should be turned off right now. There we go, it's turned off. Okay, yeah, it's just like a signal. Okay, cool. Then, you know, it's fun. I think I'll share the link to this Tinkercad on Discord. Okay, but yeah, code is basically the same one. Just so it doesn't happen like me, just be careful with your hardware. Cables always have the cables with colors. So I know that purples are triggers, I'm sorry, echoes in this case, yellows are triggers, greens are for the relays, and reds are ons or 5 volts or positives. Blue ones are negatives in this case. And I don't know, we have like a pinks here that are LED wise. Okay, cool. Nice, H bridge. Yeah, we don't have an H bridge. For some reason, Tinkercad hasn't had the H bridge. But yeah, if you don't have an H bridge, do use a relay. In this case, we have this one. And you see DC 5 volts, which is, it needs 5 volts to trigger on. And 5 volts, it's what Arduino gives you, which is like the high. So this means send 5 volts, send 0 volts. Cool. Nice. Awesome. So I'll share with you the link to register again, just in case. Let's see, it's here. Let's see, where are you guys? There we go. Nice. Cool. 1 and 2. Okay, register if you haven't. Okay. Thank you for joining. Then it was interesting. Hardware is always a little bit difficult to work with, especially when you want it to work at the first time. It usually doesn't. Like that's how hardware works. If usually code doesn't work at the first time, hardware happens like a lot more frequent that it doesn't work the first time. Okay, but yeah, that's why I have my cheat sheets. Cool. I'll be sending this one on Discord later. But yeah, I do have another stream later today in 2 hours about Docker and AI with Docker. So if you want to join me, it's in 2 hours, which I'll be really happy to. We have now with Alberto, introduction to GitHub Actions. That looks really interesting. So go check it out. It's happening in 10 minutes. So if nothing, then thank you for joining. It was really cool. Hardware again is something intimidating, but when you work with it, give it a chance and you'll like it. I promise you. We have different. Just to close, we have another. Um, we have another microcontroller, which is this one. This one, I think it works with. Let's see. Yeah, it's like an Arduino. I've never worked with it before. It's like a small version of Arduino. It's called Atini or Atini. Okay. I usually burn my fingers with the oven-driven transistors with real hardware. Yeah, it happens. Like when you're working with hardware, you just know that something has to happen. Okay, if it's not a transistor, it's a capacitor that you just blew up. Um, if it smells really bad, it's a capacitor or a battery. If it's just if you burn yourself, kudos to you because you're having fun. Just be careful. But yeah, cool. So go and join our next streamer in 9 minutes, and I'll leave you all. Thank you for joining. Ping me on Discord if you need any help with the MLH Fellowship. I'm a streamer, but also a pod leader. So yeah, would be happy to help you. Giving you some advice on how to go in. Okay. Cool. Thank you, and see you all in 2 hours if you are there. Okay. Bye bye. Thank you.